Welcome to our online meetup, Overcoming the Challenges of Microservices Deployment by Using PaaS on Openstack. Before I hand over to John Wetherill from ActiveState, who will give a more detailed introduction, let me share some logistics with you. If you have any questions, feel free to share those via the chat window on the left-hand side of the ReadyTalk conference panel. And this webinar is going to be recorded, and the recording is going to be available roughly 24 to 48 hours after this session. And with that, let me hand over to John. John, the stage is yours.
Great. Thanks, Rafael. Much appreciated. Yeah, my name's John Wetherill, and this morning we will be covering a fairly interesting discussion on overcoming the challenges of microservices development with PaaS on OpenStack. We've delivered several of these webinars in the past covering PaaS, microservices, and OpenStack related topics. This is, I believe, the 5th one we've done. And I'm really pleased today to be joined by several folks from Souza who have offered to lend their expertise and their insights and show off some of the things they've been doing. So I'll start off with a quick introduction of myself. I'm technology evangelist at ActiveState. I've been here for almost 3 years. I've been focusing hard on PaaS, containerization, continuous delivery, microservices, and a few other cloud development related topics. And so that's kind of my focus these days. And what I'll do is let's go around the room and introduce. So Frank, do you want to kick it off?
Sure, yeah. This is Frank Rigo from Souza in business development. I am really a partner focused, so the OpenStack ecosystem is fairly large, and Souza does the infrastructure piece of it. So we partner with people like ActiveState to bring solutions to market. So that's where I spend a lot of time. It's an interesting space and lots to do here. I'll pass it now to Pete Chadwick, our product manager.
Thanks, Frank, and thanks, John. Hello, everyone. As you can see from the screen, Pete Chadwick. I am Senior Product Manager at Souza, responsible for our cloud infrastructure offerings, which include Souza OpenStack Cloud. And one of the things we'll talk about today is how together Souza and ActiveState can help you get quicker time to value for an OpenStack-based platform as a service deployment. So with that, I'll hand it over to Cameron.
I'm Cameron Cedar, systems engineer for Souza. I have been working with Souza for over 10 years, and as of late have been spending a lot of time in the OpenStack world and the community, and have been presenting at OpenStack Summit for the past 3 years. And hopefully today we can show you something that is quite intriguing and impressive for you.
Great. Well, thanks, guys. So I'd also like to just briefly just have a chance to introduce the companies briefly, too. So I just want to mention Staccato and ActiveState. Actually, this slide should say ActiveState on it, too. So we're based out of Vancouver, Canada. We've been in this industry for 17 years building software for developers and cloud. And so we have language packs, we have an IDE, and we've more recently dove into the PaaS space with Staccato, which is a Cloud Foundry platform as a service, which is getting a lot of traction and adoption as PaaS is really picking up these days. And so that's kind of just a very brief introduction to ActiveState and Staccato. If you guys want to say anything about Souza, before you do that, I should mention that until recently I thought your company was pronounced Souz. And I think that's because we're Canadian and everything, there's like moose up here, so it kind of rhymes. But now I understand it's actually Souza. But yeah, if you want to just...
We actually have a, we actually, at our annual users conference, I think the first video we showed was a guide on how to pronounce the company name.
Oh, you're kidding.
Yeah, so we've been in the Linux business for 22 or 23 years. I think we were the first commercial Linux distribution. And, in the past few years, of course, we've had a lot of our customers now exploring moving to the cloud, either to a private cloud solution, a public cloud solution, or some hybrid solution in between. So over the last several years, we've introduced our OpenStack distribution, Souza OpenStack Cloud. And I think now we're on version 5 of that. Pete can talk a little bit more about that. But like you said, John, it's an exciting space. And we're seeing also a lot of traction for people who want to move workloads to the public cloud and are using the private cloud either for dev test or even now starting production workloads in the private cloud on OpenStack. So like I said, we're very busy there, lots of opportunity, especially around platforms as a service, as you pointed out. So yeah, very happy to have this partnership with ActiveState. I think it's going to be very fruitful. Pete, was there anything you wanted to add to that?
No, I think you covered the key points. And as you said, one of the things we're starting to see increasing interest from customers on is actually using OpenStack as the basis for their platform as a service. So, this discussion with ActiveState is very timely and addresses what we see as a really emerging trend in the marketplace.
Yeah, there's no question it's a trend. It's just picking up like crazy. I did want to just put up this slide too as well. Just we did announce a formal partnership with Souza a few months ago, and we are definitely on board with making sure these two platforms work very well together. So basically, that's what we're going to be. Some of this is what we're going to be looking at today. And during the discussion, we're also, if time permitting, we have 45 more minutes or so. We've got 4 people here. We're going to discuss many of these issues. So some of the barriers for entry to OpenStack and some of the challenges and then how to overcome those. So we've got a lot of interesting stuff to talk to. But before we do that, we are going to be showing some demos. And what I'd like to do is, Cameron, if you're ready, I'll hand over the presentation screen to you so that you're able to kick off the demo, and then we'll return back to the talk. Does that work for you, Cameron?
That works for me, yep. That's fine.
Okay, see if I can do this. Gotta make sure I click the right button here. So it would be. Yeah, I think I just transferred it over to you.
So everybody should see my screen now.
By
so
the way,
what
Cameron,
we have
where are
here.
you based?
Sorry, where am I based?
Oh, where are you sitting? It's always good to know where everybody is when we're doing these online demos.
I actually live in Boise, Idaho.
Oh, okay. That's a ways from here.
The technology capital for OpenStack, by the way.
Oh, really?
It's getting there. Yeah, there's a few meetups here, but yeah, they're small in comparison to some areas like Silicon Valley.
Like Silicon Valley, yeah.
So what I'm going to show you here today is our batch deployment. Now, I did get the environment ready to go so that all the systems were up and running and were joined to our administration server, which we call Crowbar. Crowbar is an open source tool that we use to deploy our cloud framework. It works in conjunction with Chef, and it has functionality in here to allow us to deploy all of OpenStack. And also, more importantly today, it also allows us to deploy a full high availability environment for our control plane as well. So I'm going to show this to you. As you can see in here, we have all of the components for OpenStack that are available so that you can install those. Now, I'm not going to edit and or create any of these through the web interface. I'm going to go to the command line on the administration node. Everything, as you can notice, is running under VMware Workstation in this particular demo environment. There is a Crowbar batch build, and I have a small Llamo file which has the entire configuration for the cloud that I'm going to build today. So I'm going to execute that. I have that spelled wrong. And as I execute that, HAE repositories have not been set up. Something I didn't check on this particular. We might actually have to do the simple cloud today.
That's totally fine.
This one will just, it won't do the full HA, but it will actually have full cloud deployed.
Yeah, we can talk through the HA thing. That's no problem.
So what it's doing now is it's actually provisioning the various components to OpenStack. So let's go ahead and switch back, as this is actually deploying right now. This is really rather boring. So as this is going forward, we'll go ahead and
Cameron,
switch.
just one quick question before you do that. What is, you don't have to go show it unless you want to. What is in that YAML file you loaded up there, approximately, just a high level?
So inside that YAML file, you have an output of various configuration for the components of OpenStack, like Keystone, the database, RabbitMQ, Cinder, Neutron. It will have what nodes are a part of each one of those, that kind of thing. So in that deployment YAML file, you'll also have exactly what nodes are being defined for each component of the OpenStack framework. So, if you have the compute infrastructure that's being used for Nova, it's automatically selecting which nodes are going to be used for Nova inside that configuration.
Nice.
So ideally, you would go through your deployment beforehand, and then you could actually do a crowbar batch command and actually dump out your entire configuration into a YAML formatted file. And you can take that formatted file and recreate your cloud at any time.
Very nice.
So
that's very helpful. Yeah, I was curious what went on in there. Okay, so yeah, feel free to transfer it over to Pete, who can take the next part of this thing.
Great, thanks, Cameron. So what I wanted to do is while that's going through, is walk through some of the discussions, to give you some additional background, not only of what you're kind of seeing in the background, but also just give you some idea of what our focus is at Souza around OpenStack. I'm not going to spend a whole lot of time talking about OpenStack specifically. I assume most people kind of have a background on that. But this is one of the things that we see as the core drivers behind enterprise or organizational interest in private cloud computing. And when we say
before you go too further, I don't see your slides. I'm not sure if control has been transferred over to you yet.
Good point. Let me try that again. How's that?
That's much better. Thank you. Very good.
Okay. All right. Sorry about that. So these are the things that we see as being the drivers behind why people are interested in private cloud computing. And understand when we talk about private cloud computing, that encompasses both OpenStack, which is infrastructure as a service, which is what Souza has been focused on, as well as solutions such as Staccato, which address more platform as a service. Both of those are different approaches to private cloud computing. And the first point is people are looking at it to drive down costs by increasing the level of automation required to get business services up and running in a IT infrastructure. And more importantly, the whole idea is to be able to deploy new services rapidly in the face of changing business demand. Either because you're spinning up a new business or you are have increasing levels of web load because you're got some specific event that happened, a product launch, whatever, or you just need to deploy resources to address short-term IT requirements. And you want to move much more towards a more self-service provisioned environment. So if you think of public cloud, Amazon, Google, Microsoft Azure, being able to just log in and quickly spin up a couple of VMs to do something, or in the case of a platform as a service, be able to have a whole application framework that you can use to quickly spin up an application to address your requirements. The whole idea is around getting faster time to value. So how do I go from I need this capability to having it up and deployed to my end customers as quickly as I can? Now, clearly you can do a lot of this with public cloud, but what we're hearing from our potential customers and existing customers is that they really are concerned about wanting to keep some of their applications, some of their data installed at the local data center behind the firewall, and they can manage that with the same sort of security framework and security processes that they've been using for their enterprise applications for years.
You know, Pete, I talk to a lot of enterprises, a lot of banks and financial institutes and health, companies, and they are wanting to move to the public cloud, but they're pretty much unable to for a lot of reasons, regulations and just process, and they just really need to retain the data behind their on-premise, behind their firewall. So that's why we need to keep doing these.
Yeah, good point. Excellent point. Thanks. So again, I'm not going to spend a lot of time talking about what Openstack is, but essentially it is software that deploys what is called infrastructure as a service cloud, and this diagram really represents the standard definition of what a cloud is by the U.S. National Institute for Standards and Technology, which says that you have a pool of virtualized resources, typically compute or storage nodes, but also increasingly networking capabilities. Some people refer to that as software-defined everything. A set of standardized APIs that allow you to automate the deployment and management of services running on that pool of virtualized services or virtualized servers, and then you've got a portal that allows your end users to access that. And by extension, platform as a service just takes that one level up, where the self-service portal also includes access to more predefined application environments, more greatly simplify the process of spinning things up. So just as background, Souza has been involved with Openstack since 2011. As Frank said earlier, we've been in the open source business for about 20 years. We were the first fully supported enterprise distribution of Linux, and we view Openstack as the same way. It's an open source project. It has a great community around it, and we're able to participate both by moving the project forward as well as by bringing the project as a commercial solution to customers. So we really started picking up activity in 2012 when we launched our first release of Souza Openstack Cloud. And similar to our Linux heritage, we were the first to deliver a fully enterprise-supported Linux distribution. We were the first out to market with an OpenStack distribution targeted at the enterprise. Some of the things we've worked on: security enhancements, the ability to support multiple hypervisors in a single cloud, and as Cameron started to show in his demo, an installation framework that was built upon another open source project called Crowbar. 2013, we came out with our second release that included what we call mixed hypervisor cloud, so you can now deploy an OpenStack framework that contains compute nodes that perhaps are running, some of which are running VMware, some of which would be running KVM. You can also include Xen or Hyper-V. And the idea is twofold. One is to provide the flexibility that enterprises have in their environments today, as well as provide a platform as they go forward that can adopt different kinds of solutions based upon the workloads that they're trying to deploy. And then in 2014, we actually made what we thought was a major push forward in that we automated the deployment of all of the OpenStack control capabilities in a highly available configuration. The importance of that is as we started talking to customers and they started moving away from, okay, I'm trying out OpenStack to see how it works and doing some simple projects with my development and test organization, as they start to see this as being a framework that they're going to start building mission critical applications, then you need to make sure that the underlying infrastructure is highly available. So that was what we focused on. So when you go and you deploy things like your strategic platform as a service on top of OpenStack, you can have high confidence that the underlying infrastructure is solid. Real quickly, we've been participating. We're a platinum member of the foundation, so one of the founding members, Alan Clark, who's our director of community involvement, is chairman of the foundation board. We did launch an OpenStack distribution. We'll talk about that in a little bit. We're working within the broader Open Souza community to drive awareness and adoption of OpenStack, and then we're actively making technical contributions upstream to the project. So one of the questions we get is, well, why use an OpenStack distribution? Why don't I just download it from OpenStack.org and do it myself? So this is kind of what doing it yourself looks like. It's freestyle Legos. You get a tub of Legos, you pull them together, you've got a lot of different options, and you have flexibility. But there are still 1,400 parameters that you need to specify. You've got 11 components and increasing that you need to get working together. And we've had feedback from customers and partners that it can take weeks or months to get up and running, if in fact they can get it up and running at all. And analysts even talk about the need, if you're really going to do OpenStack on your own, you're going to have to go hire a fairly large team, build up the internal skills necessary to do that. The trade-off of going to a distribution is this: you get a Legos, you get it's something that's designed to work together, and the whole idea is that you want to drive down the time to implement from to hours. And as you see, Cameron kicked off a process to go deploy an OpenStack Cloud, and he did some pre-planning ahead of time to make that all work. But hopefully by the time that I finish talking, and we go through some more discussions around the Staccato solution, and we hand it back to Cameron, everything will be up and running. That's the real value, is how do I get this to my end users quickly, rapidly, and in a way that's reliable and supportable over long term, and at the same time is scalable. So as my requirements grow, I can grow my cloud, I can add new capabilities on top of it, and it becomes a core part of my solution. So real quickly, this is what a distribution looks like. The boxes in orange are the actual components of OpenStack. But to make all that work, you need things like a message queue and a database that enables all of the services to talk to each other. It's obviously got to run on a hypervisor. The hypervisor typically needs to run on an operating system, and then you've got physical infrastructure underneath of that, typically x86, 64 commodity servers, as well as switches and storage. And then you'll see there's a networking component called Neutron and a virtualized block solution called Cinder, and those have adapters that reach down through the operating system to talk to the actual physical infrastructure, storage of the switches, depending upon whether we're talking about block devices or networking. And the whole idea is you need to have all this wrapped together. It has to be installed in a very specific, precise way, which is why we deployed our framework that Cameron was demoing. And so what we did was when we came out with our Souza OpenStack Cloud, right from the beginning, we had the installation framework that on the left-hand side of the slide that Cameron was talking about, and then we deploy all of the functions have it configured to work with certain sub-packages like RabbitMQ, PostgreSQL. It all runs on Souza Linux Enterprise Server, which means that it's fundamentally supported on pretty much all modern hardware that's running in customer data centers today. We are Souza Linux Enterprise Server is certified on all major server platforms, and that allows customers to deploy on existing infrastructure as well as to expand that infrastructure confidently that things are just going to work. Similarly, we have
I have a quick question about this, Pete, if you don't mind. I just want to clarify one thing. So I come from the application layer, and obviously at PaaS we're doing lots of app stuff. And just want to clarify, you mentioned RabbitMQ and Postgres, and those are specific for OpenStack itself, for the operation of OpenStack. Is that true? And they're not for higher level application. It's not like the app users would be using that. That's for OpenStack itself, right?
Yes, correct. I mean, one of the key things is, as I'm sure you can understand as an application enabler, is that you really want to make sure that your control plane is secure and isolated from your application plane. You just don't want people being able to hijack a service by getting access to the same message queues. So to a large extent, the OpenStack infrastructure runs on an isolated set of network interconnections. They can be virtual networks, but they're still separate. You typically have a dedicated storage network, a dedicated administration network, and then the applications sit on top of that and can get access to resources through, and you can see the cloud APIs, OpenStack and EC2 APIs in the middle. There are some projects to start providing things like a standardized message queue API that would run as sort of a service on top of OpenStack that would enable things like a message queue to be deployed easily cloud. But that's sort of a higher level capability beyond just the core OpenStack functions.
Right, and that's the kind of stuff that the PaaS would provide anyway. So very good. Well, thanks for clarifying.
Sure. So just a one slide, kind of sales pitch here. Souza OpenStack Cloud 5. It's based upon Juno. If you know OpenStack, every 6 months there's a release. The most current release that just became available last month was Kilo. But some of the things that we focused on, we now support Souza Linux Enterprise Server 12 as compute nodes, and we've made lots of enhancements in terms of integrating with a storage product based upon another open source solution called Ceph, and then we're providing increased levels of flexibility in services such as database as a service or analytics as a service, which is centralized around big data, and then we've had a lot of improvements to our HA configuration. So with that, let me turn it back over. How do I make this? So we can. There we go. So John, if you want to go through and take control and go through your presentation.
Very good. Yeah, thank you.
Any questions that we want to pick up from the attendees at this point?
Okay, yeah. So let's move on a little further. We will give Cameron a little bit more time to finish the installation of his stack there. First of all, I want to make sure everybody can see the slide that says PaaS under the hood. Is that what you're looking at?
It is.
Great, very good. Okay, so we've been talking about the infrastructure layer just now and how rapidly that can be provisioned, which is very important part of this whole thing. Instead of spending, as Pete mentioned, months or weeks trying to configure an infrastructure, it can be done in a very short period of time. And that's exactly the thing that we are doing at a higher level at the application plane, so to speak, where we want to avoid the requirement that users or developers or DevOps and dev teams have to spend a lot of time with the underlying plumbing. And so now with the infrastructure layer rapidly provisioned, we're moving up one layer and doing exactly the same thing at the application layer. And what this slide illustrates are many of the things that are provided in a platform as a service. And I'll start off by just calling out at the bottom where it's the infrastructure layer. So what we've been seeing earlier is that's being built up on OpenStack, and the PaaS is actually independent of the infrastructure layer. So it runs beautifully on OpenStack. It also runs on other infrastructures as well, the VMware vSphere infrastructure, or on AWS, or on any Cloud Stack and Cloud Platform, which is from Citrix, and other platforms. So it's basically an abstraction layer above the infrastructure. But it does tie or work very well with OpenStack, and it hooks into it for things like scaling and some other features. And so above the infrastructure, this is where the PaaS itself comes into play. And you can see it provides instantly a number of languages and frameworks and runtimes and containers that are available instantly for the applications to use, such as languages like Java and Perl and PHP and Scala, etc. These are all provided out of the box. There's also frameworks like Spring and Bottle and for Python and others that are also available. And then containers that these things need to run in, like Tomcat and Nginx. So to deploy an app to the cloud, to the PaaS here, to the cloud, you don't need to download and configure and maintain all of these languages and frameworks and runtimes and containers. They're just provided as part of the PaaS itself. And these are, in Staccato specifically, we're using Docker to house or host the applications. So we use Docker containers. And I should mention, I just got out of DockerCon the last 2 days in San Francisco. And that was one of the most high energy conferences I've ever attended. And I've attended a lot of conferences. So Docker is just, as everybody knows, it's taking the world by storm. And much of the focus of the conference was at a higher level. What do you do? Now we've got these awesome Docker containers. How do we orchestrate and manage these things? And that's exactly what Staccato does. It's very proficient at managing and orchestrating containers and everything above that. Containers are a good start, but there's a lot more that's needed to get an enterprise application out in the cloud. Logging and monitoring and scaling and versioning and high availability and securing and all that, integrating with security services like LDAP or Active Directory. So all this is provided by Staccato. And so I'm also going to dive a little bit further and just look at actually what you get in a PaaS, what Staccato looks like under the hood or the architecture itself. And I'll just whip through this fairly quickly. We don't need to get into too much detail. But the red circles in the middle, those are DEAs, those are droplet execution agents. These are VMs which are responsible for running the application containers, the app containers that run the apps or house the apps. And so there's any number of those DEAs with those VMs. And then on those, there's multiple dozens, hundreds of containers running that the apps are contained in. And we have routers above that are load balancing or routing between each application instance. So you might have a single app deployed that has hundreds of instances out there, and the routers will load balance between them all. And very important component, the cloud controller. This orchestrates the entire PaaS. It exposes an API, a RESTful API that you can use to access and query and manage the PaaS itself. And so the end user of the PaaS, the developers to start off with, would be using the API, the Cloud Controller API, or some clients for that API to manipulate and access the PaaS itself. For example, to deploy applications, to find out what the state of your apps are, how much resources are used, creating users, all the things that you would do with the PaaS. There's a lot of functionality there. And At the bottom, it lists some of the external feature or facilities that the PaaS can make use of, like monitoring tools. New Relic and Nagios and App Dynamics are examples. Logging. It's very trivial to redirect all the logs for all the application instances out to an external logging provider. And a number of other things too. Also, we do provide a number of services, database services, messaging services. So we have RabbitMQ in here as well as Postgres, which is what prompted my question earlier. So this RabbitMQ and Postgres, as well as MongoDB, MySQL, Redis, and a few others, are meant for at the application layer and used for applications themselves. So having said that, I would like to show this in operation, but before we do that, I think it makes sense to, if Cameron, if you're ready, I can hand it back to you, and you can show the the next. Yeah, so I'll hand it back to you, and let's see if I can just do this. Let me know if that works.
I think we're all good to go. Everybody.
Good, I can see your screen.
My screen. All right, perfect. So I'm going to scroll up a little bit. So the batch deployment did finish, and I actually have, if I go over to my Crowbar bar clamps and I look under the OpenStack bar clamps, I have a number of them which are green now. The database has been deployed, RabbitMQ has been deployed, Keystone's been deployed, Glance, Cinder, Neutron, Nova, Horizon, Heat. Kilometer and Trove are not deployed, although we could automate those as well. I selected to install a simple cloud stack, so it's very limited on its functionality at the moment. So let's take a step back just a little bit and take a look at if I were to deploy the HA bar clamp has a cluster that's been set up in here, and there are a number of things that this particular setup has defined. It's using DRBD for the database and the messaging queue, and so it's setting that up in a 2-node cluster for those particular services, and we're selecting the cluster members for Pacemaker for those, and then we can go ahead and select apply, and it will actually start installing the right software and setting those nodes up. When you have the cluster components all deployed, you can go back to the OpenStack services, and for the case of, say, the database, instead of moving a single controller over here, I would actually have a cluster that would be available on the available nodes section on the left, and I would just drag that over to the database server side, and it would deploy that database on a cluster instead of a single node. That's really some of the difference there on the deployment. But the high availability is completely automated. You literally don't have to do anything manually other than messing with the Stoneth devices if you want those deployed in your HA environment, which is highly recommended in your production deployment. You may have
Cameron, so all of this, sorry to interrupt, all of this is represented in that YAML file that you originally configured or deployed from earlier, right?
Mm-hmm. Correct.
Yeah,
we can take a look at that YAML file just briefly.
Yeah, maybe that would be helpful.
If I look at the one for HA, you can see the cluster components that it has in here. You know, the Stoneth is set to a manual mode in this particular case. You could set it to deploy a specific Stoneth device if you had Sonos devices available within your hardware. Notice how it's got all the elements configured for the cluster setup. It has the two controllers configured for pacemaker and for the Hawk web interface for monitoring the cluster. And then for the database, notice how the database server is selected as cluster. So it deploys the cluster. It's got DRBD set up for the storage infrastructure. If you keep moving on to the messaging queue, it also has DRBD in the cluster. So each component of OpenStack is in here. You'll notice Keystone and Glance, Cinder. It's a very simple configuration, and it's easy to configure through the Llamo format. It really doesn't take a whole lot to utilize this to create your entire cloud. Yeah. You can see it's a very simple format. I could, in fact, do a crowbar batch, and it has a number of switches available to it. One of those is the export switch. And I could actually export my current format into a YAML format. And I could give that export a name, simple.yaml. It's wanting a specific bar clamp to be included. So I would need to give it a bar clamp list. So if I wanted to export database, and then export Nova, Glance, I would put that in the list here for what I want exported into my YAML file. So once you have your cloud configured, this is a great tool to go back if you need to recreate a cloud or you're doing multiple clouds in various locations. This is a great way to recreate that infrastructure. That's our batch deployment, fully automated infrastructure. At the past 3 OpenStack summits, Intel has been putting on the Ruler of the Stack competition. It's interesting because it's all based on reducing the amount of time for deployment, and that's interesting. But what's more interesting about that is actually what we can do, what's actually being deployed. We've been able to win that competition every single time, and we've been able to deploy OpenStack and all of the required, there's like bonus sections where, if you deploy, say, heat, or if you deploy HA, you get a certain number of bonus points and you get a reduction on your time. Well, we had a negative time last time, and it was like, something like -9 minutes or something of that. I can't remember exactly, but what's more important there is not the amount of time it took, although we can do it really fast and it's really quick in this automated fashion. Take a look at what we can actually do. We can actually deploy a full, highly available environment through that automated deployment. That's impressive. There's also some other things that we can do rather quickly as well, and that is starting up an instance in the cloud, deploying Zen and KVM as hypervisors both, making sure that you can do live migration. This is stuff that can be all automated through our batch deployment, and it's working. And it doesn't take a rocket scientist to get everything up and running. So those are some of the key things to get from that is that, it's not just all about speed. It's the fact that, we can do all this stuff, and we can do it in a timely manner. and these are some things that we've had feedback from several people, like Pete was saying, is that it's hard for them to get up and running. They might hit a roadblock on one of the OpenStack components, whether it be Nova or Glance or Keystone. They just, for whatever reason, get stuck on some of the parameters and can't get it properly deployed. And so this is where an OpenStack distribution can really help out in a lot of these situations.
Right. So a little bit about the timing then. So I like the -9 minutes thing. It'd be cool to actually deploy it in -9 minutes. but just curious, how long does it take effectively? I mean, what you deployed earlier took 15 minutes or something to get a full HA stack running?
Yeah, the simple cloud stack will take about 12 minutes, and then for the full HA, it takes about 18 to 20, depending on the hardware and the size of your configuration that you're deploying there.
Yeah.
So, and that's pretty speedy. Speed isn't everything. You absolutely want to make sure that everything is up and running and that you can actually use it. Okay. So I actually have the full cloud up and running now. I do have the control infrastructure. If I take a look at some of my nodes, my controller 1, he's actually, he should have the cloud dashboard running on him. And let me go ahead and open that up. It's just getting the IP address that was being running on.
Yeah, and just to amplify the point, as Cameron says, it's not necessarily just about speed, it's also about accuracy. But the other point is, if someone's looking at deploying Staccato on top of OpenStack, here's a quick way to get OpenStack up and running, and now you're ready to go and start working on the deployment.
Yeah, absolutely. So I now have the Horizon dashboard up. Of course, it's been skinned with our Souza skin, and from here I could go in and add and modify my flavors. I could go in and add in some images. I can create an image for this environment. Image location, I can grab it from a file, browse for it. I've got a number of images here that I could use on my local machine. If I wanted to deploy something as far as like an Apache web server, and I could upload this currently into my environment. So I can select the minimum disk sizing and do 5 gigabytes there. We'll make this 512 RAM. Make it a public image. We'll create the format, the QCAT2 format for KVM, and we'll go ahead and create that image. And it's just uploading that right into Glance at the moment. And it just takes just a few minutes. It's just a 400 meg image. Now it's active. I can take that image and switch over to my OpenStack project and actually launch that image currently. And we'll just call it Cloud 9. And I'm going to use kind of a medium size. And that ought to do it. This and security. We're just going to take some very basic defaults and just launch it. And oh, this is an error because of my flavor doesn't match the image there. So we can go ahead and modify that flavor. And in fact, we'll go ahead and create a new one. Virtual CPUs, we'll give it 1. We'll just call it Souza small. We'll give it the button there on the keyboard. 512 of RAM. Root disk, we'll give it 5 gigabytes. 12. And then the access. Admin, create the flavor, use an ephemeral disk. Flavor. We should now be able to launch that from our project. 9, Souza small is already, it notices that it fits with that image. Go ahead and launch it.
Okay.
And it's now building that. We can delete this other instance there.
Okay,
so
very good. I realize,
that.
Cameron, we've got about under 10 minutes left, so there's a few other things we should cover. So
yeah, sure.
But that looks very powerful. So I just want to, I mean, we did part of this webinar was to address some of the challenges of microservices, which I just want to make sure that we're able to address a couple of those. And actually, the focus of this webinar was much on the underlying, the kind of the plumbing. There's a ton of challenges that microservices developers and adopters are facing today. The lack of mature tools, the lack of developers and people with experience with it, the requirement to go to DevOps kind of mindset and culture. But one of the big ones is just the increased operational complexity and overhead of building microservices out, and there is a lot of extra complexity. So the kind of the point here of this webinar with you folks was to just illustrate that a lot of that complexity goes away when we use tools like what you've illustrated, and as well as PaaS. So we don't have time to cover a lot of the challenges of microservices, but I do want to make it clear that a lot of these, the operational complexity challenges and barriers are alleviated significantly when we actually have a platform like this. The other thing I want to point out here is, or mention or discover is, maybe you guys can answer this, is we just had a question from one of the attendees saying, having the first deployment up is great, but what happens if you need to do 100 deployments? What do the admins need to consider?
So if you want to do 100 deployments, there are a number of things to consider. What are those deployments revolving around? Are they ephemeral images that you're going to spin up and spin down? Are they going to be something running in an application that you might need to take care of a little bit? Consider those things. Do you need to scale up and scale down the environment? You may want to use heat to do those 100 deployments. And use heat stacks in Openstack. So you can scale those up and scale those down based on CPU utilization, disk usage, and various other metrics in conjunction with Ceilometer. There's a number of things to consider when you start talking about doing 100 deployments. If you're doing 100 deployments of Openstack per se, you need to consider are these OpenStack deployments going to be on similar hardware? Are these OpenStack deployments going to be set up the same? If not the same, are there similarities? Can we do this through the batch deployment? There's a number of things that you can think about there to make that process easier. I can certainly help with a lot of those questions that you might have.
Yeah. That's very helpful. So yeah, and by the way, for the attendees, feel free to, if you want to ask additional questions in the last couple of minutes we have, feel free to just send them via the chat window, and we'll get to them as we can. What I'll do quickly, just as while we're here, is now that the infrastructure is ready to go, it is then pretty trivial to deploy a PaaS to this infrastructure. And I'm just going to buzz through some slides here to just talk briefly about Staccato and deploying it on OpenStack. All that's required to deploy the entire platform as a service stack is to just boot the image that we provide onto the OpenStack instance that was provided earlier or configured earlier. So it's just boot an image and you're done. You have the PaaS ready to go. There's no additional configuration. Some of the other PaaS out there, it takes, just like the discussion earlier with OpenStack, is that there's a lot of underlying plumbing and a lot of issues you have to deal with where it could take several days or hours at least to configure your PaaS. And we've spent a lot of effort to eliminate those barriers so that deploying Staccato literally takes maybe 3 or 4 minutes. So once you boot that up on the infrastructure that was just created, we see a login window. And actually, the first thing that happens, I've already created credentials, but after that, you're able to log in. And once you log in, you have access to the web console for the PaaS. And we don't have a lot of time to get into this at all. But at this point, I've got the PaaS available. This is the web console to access it. And from here, I can deploy an application. We have this concept of an app store. It's a catalog of applications that are available to be instantly deployed. You'll see that there's Python apps and Perl and Ruby and Java and PHP and JavaScript apps, as well as a number of Docker-contained applications. So if you have a Docker image ready to go, you can deploy it to the PaaS simply by clicking a button. And what I can do is, for example, I've got this Python currency converter application, which I can deploy to the PaaS. And I do that simply by clicking a couple of buttons and hit deploy. And what this is doing is grabbing the bits for this app from GitHub and pushing it out to the PaaS itself, creating a Docker container to house it, and wiring up any other dependencies. This application actually makes use of Redis, so the PaaS Staccato takes care of wiring up the application to the Redis data service as well. So the point here is that this all happens with the click of a few buttons. Not only to get your PaaS up in a few minutes, as well as your application deployed to the PaaS. So what I'll do is, and just quickly, now that it's running, I'll view the app in the browser. So it's a trivial app, but it's actually a 3-tier application. It's used for currency conversion, and it's making some web service call out there. But it shows how quickly it is possible to deploy an application to the PaaS. So having said that, we're actually, I can't believe this, but we are out of time already. And what I'd like to do is just let's wrap it up. So any last words, any one of you? We've got about a minute left to go.
John, this is Frank. I just wanted to make sure the attendees saw the link that Cameron posted in the chat window. So we do have an appliance that installs the OpenStack admin node. So it really is a good way to get started if anybody wants to visit that link, download the appliance and get started that way. It shortcuts a lot of the things that you would have to do manually as far as configuration. So that's a good place to go.
Yeah, I was at the Souza Con in Orlando last year, and I think you were handing out USB sticks that had everything you need to configure the entire stack, which is pretty cool. Just plug in your USB
that's what
stick.
that is.
Nice. Okay. We are out of time.
We've got a question there in the chat.
Oh, go ahead. Yeah, what's the question?
There's a question there in the chat about Windows and .NET with Staccato.
All right. So we do have some support for Windows and .NET through Mono framework. And it's not our primary focus, but as the Windows support is evolving with Docker and things, we will be focusing more on it. I will say we do focus more on there's a lot of background noise happening somewhere on the line. Okay. Anyway, we are out of time, so I'd like to thank Frank, Pete, and Cameron for joining me on this call, and all the attendees for being as well. So, thanks you guys for the discussion.
Thanks, guys. All right. Yeah.
Thank you.
Thanks, everyone. Bye.
Thank you, everyone. Goodbye.